Hello, this is Anthony Sylvie here. Welcome back to another run through of a coding problem on LeetCode for the Nico 150 problem set that we've been doing. This today. I'm going to be completing the final problem and the set for arrays and hashing today, and it is going to be the longest consecutive sequence problem today. All right, so let's take a look at this problem right here, and I'll just start reading. So, given an unsorted array of integers and noms, return the length of the longest consecutive element sequence. You must write an algorithm that runs in O of n time. All right. Okay, so we got an array of numbers. It could be negative. It could be positive. It could be very, very large. So I don't have to worry about since I will be coding Python, but I would maybe try to use like longs or something to store integers if I was using a static type language like C++. So keep that in mind, but numbers, the longest consecutive sequence is 4. And then that sequence is it's 1, 2, 3, 4. Okay. So it looks to me as if we're not exactly like looking for subsequences of arrays, that is, what I mean by sequence and a subsequence is that a sequence is really just a set of numbers, and the subsequence is more like a part of the array that may not be consecutive elements in an array, but they still go in order from left to right. We're talking sequences here, not subsequences. Long consecutive subsequence is going to be another problem. It's a problem. So here, order is not going to matter too much. We're just picking out elements, and that's how we get our final element sequence here, and we have it set. All right, and then input for numbers. For example 2, we have numbers ranging from 0 through 8. We have 1, 2, 3, 4, 5, 6, and 7 as well. All right, so we have all the numbers from 0 to 8. So that would be an output of 9. Okay, perfect. All right. So I think we could give this a go now. Let's write out a little planning section here. So let's start up. I'm going to take a moment to recognize what is probably going to be one of the more obvious solutions when we first look at this problem. That obvious solution is sort. So let's go ahead and take a look here. So one thing we could do is sort nums. Right? And then, so we could sort nums actually because it'll actually be easier to find subsequences here. Here. So like if we arrange the numbers, we could start like a counter. We start with a counter value, and then go up every time the next index is one more than the previous one. And if we run into the element that fails to meet the criteria, fails to meet the criteria, we stop at the top, make our answer, make our answer the length of the sequence that we found, and then we keep going from there until we run out of elements in the nums array. All right, so we'll have a counter value. We'll set it to 0. Actually, no, we're going to set it to 1 because what I'm going to do is end up using a for loop starting at index 1, looping all the way to the last index, and in each iteration of the loop, we would we would we would take the index and compare it to the element at the index before it. That's not going to work with a 0 index, obviously. So we're just going to say that the counter is going to be set to 1 for now. All right, and then we'll have a final answer value set to 1 for now. All right. Now we have a for loop. We're moving through nums. And then we check to see if, okay, so here's the first case we want to consider. If so, we want to check if nums I is actually equal to nums I minus 1. I might as well add this note here. So we got starting index at 1 and use index I. All right. So now we check to see if the 2 consecutive elements in our sorted array are going to be equal. So then there's 2 possibilities. First, the first possibility is to check if I is going to be equal to if nums I is the last element. Then we're gonna compare our counter to the answer. So we would have to use the max function in this case. All right. So this is the line of code that we're gonna be using to check if we found a longer sequence of numbers or not. And if we have found a longer sequence, we put that as our answer. But anyways, the second possibility that we run into, if 2 consecutive elements are the same, is to just simply move on. The other possibility is, all right, so the next possibility we'll consider for consecutive elements is whether nums I is equal to nums I minus 1 plus 1. And then this is where we increment our counter. And then once again, we have to check to see if nums I is the last element. So it'll just be the same thing as this. Whoops. All right. All right. And then lastly, we have one last possibility where we have a break where the next element in the sequence is not 1 plus 1 bigger than the last element and is not equal. Okay. And that's where we reset counter to 1. We use this. So we set our answer to what our counter is. If the counter is bigger than our previous answer, and then we reset counter to 1. And after all that, when we loop through all the numbers in the array, we return our answer. All right? So pretty simple solution. So a lot of instructions to consider here, but on all fairness, it's not really that difficult to implement. However, we definitely must consider the fact that this does run in n log n time complexity, because we would end up using the built-in sort function to sort our nums array, which does run in n log n time. And our instructions actually tell us that we must write an algorithm that runs at O of n time. So we're going to try something different. And it will definitely run in time, O of n time complexity. So here's what we're going to do. We'll have to create a set based on elements in nums. All right. Then we have an answer value. We're going to set 1 as the default. And then we want to loop through the set. We'll use index n. All right, so what we want to do first is to see if the element that we are examining in each iteration is actually the first element in the sequence. So we want to check to make sure if n minus 1 is not in the number set. Because if n minus 1 is in the number set, then our number n is not the first element in the sequence that we're trying to find. So we're going to have to keep looking through the set to see if we can find it. If we haven't already, which we will have already stored a calculation for as we're going to see in the steps that follow. All right. So if we found the first number in a sequence, we'll set a counter. We'll set it equal to 1. And then we'll have to keep checking to see if a number that is equal to n plus counter is in the number set. That's how we keep finding numbers in the sequence that we're trying to look for. All right. And then we'll have to increment counter. And then once we found a breaking point, we compare our current answer to counter. with our max function. So same generic setup as the sorting function here, function here, except it runs a little. It's going to run a little bit faster, and it requires fewer lines of code, so we can return our answer. So yeah, time complexity is going to be O of n for sure. Yeah, I mean our while loop, it's not really contribute much because I mean worst case it's going to run like n times, but 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 we probably won't expect that too much. But much. Our our time complexity is still going to be O of n because our average time complexity is still going to end up being O of 1 for the while loop, probably. Maybe a little bit more. It's never going to run cost. The space complexity is going to be O of n though. That's because of the fact that we are going to be creating a set that's based on the elements of nums. But then again, but yeah, that's pretty much all I have to say about the solution. And so I'd say it's pretty sufficient. So let's give it a go and see if we can code some Python. Let's start with our number set. So this is how we're going to create our set based on the elements of nums. We'll have an answer value of 1. Now notice that I'm setting it to 1 because, well, if we did manage to find for any longest subsequence of numbers that we have, it's going to be 1 no matter what. Of course, now that I think about it, I do want to add in a quick case real quickly. Because there may be a possibility, of course, that num's length is 0. So we're going to add that little base case right there. So we check to see if length of nums is equal to 0. In which our case, our answer is going to be 0. Because there is no elements in the nums array. But if our nums is empty, nums array is empty, we can start looping through the numbers in num set. All right. We check to see if there is an element 1 less than n, or num in this case. And if it's not, we can start finding elements that are some counter greater than n, than num. So our counter is going to be 1. And then, while num plus 1 in num set, we can start implementing our counter. And then once we reach a breaking point, we return the maximum of our current answer of counter and answer. Right. And then once we loop through all the numbers in the number set, we can return the answer. Let's give this a go and see if this runs okay. Dang, this is taking a while. I see what I did. I have an infinite while loop. I meant num plus counter. My bad. Alright. Let's try running this again. See, that's a little better. Let's try submit this, see if it passes all the test cases. All right, yeah, so that definitely helped a little bit. I mean, yeah, so I mean, our memory complexity is not as good as other solutions, but we basically traded in for a faster runtime by not using the sort function. So yeah, this is definitely a pretty good solution. A pretty good solution here. Um, yeah, definitely will be a little bit harder if you had to find a longest consecutive subsequence instead. I think it's going to be a dynamic programming problem that I might have to try and solve later on. No, later on. Well, this time I don't know too much about dynamic programming, so I'm going to get a little bit more. We're definitely going to get a little bit more practice with these problems on LeetCode 150 later on. On to try to build these skills up for these. Some of these are more challenging problems, but yeah, I mean, these last 9 videos that I created were pretty helpful for getting us started with this walkthrough. 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 I mean, I will say that maps and sets are probably like my favorite like data structure to implement here. So I'm really glad I was able to use those sort of thing to start off Nico 150. We're still going to be on a race for the next few videos. It's going to be the 2 pointers problems that we're going to be doing. So looking forward to publishing those later on. But anyways, thank you so much for watching. Be sure to be sure to subscribe to my channel for updates for more coding videos and some coding demos of projects that I'm working on too. Oh, and don't forget that if you code in C++ and or Java, I will be posting solutions in those languages in the comment section below this video. So definitely check this out. Um, all right. So new set of problems are going to be starting. We're going to be starting. So stay tuned for that. In the description, I will be leaving a link to the entire playlist for arrays and hashing arrays and hashing problems, as well as the Nico 150 playlist. So definitely check those out when you get the chance. So you can see my walkthroughs of the other problems in this problem set. So yeah, definitely check those out if you got the time if you like these videos. All right. Okay. Well, thanks so much for watching, guys. So long.